December 1942. A maintenance depot outside Tunis, North Africa. A group of German mechanics and engineers stood in a semicircle around an unusual prize that had just arrived on a flatbed truck. It was an American M3 half-track, captured intact after a skirmish near Tobruk. The vehicle sat there, dusty and battle-worn, its olive-drab paint contrasting sharply with the sand-colored German equipment surrounding it. Oberstleutnant Hans Müller, a veteran mechanic who had worked on everything from Kübelwagens to Tiger tanks, circled the vehicle slowly. He ran his hand along the hood and laughed. "Look at this," he called to his colleagues. "The Americans build their military vehicles like tractors. Simple, crude. Probably falls apart after 100 kilometers." His fellow mechanics nodded in agreement. They had heard the stories. American equipment was mass-produced junk. Quantity over quality. The Reich's propaganda had told them so repeatedly. Their own Sd.Kfz 251 half-tracks were engineering marvels by comparison, precision-crafted machines built by skilled German workers. But Hauptmann Friedrich Weber, the officer overseeing the technical evaluation, wasn't laughing. He had seen the intelligence reports. He knew something his mechanics didn't yet understand. The Americans were producing these vehicles by the tens of thousands. And they were everywhere on the battlefield. "Gentlemen," Weber said quietly, "I want this vehicle completely disassembled. Every component examined. Every system tested. I want to know how it works, how it's built, and most importantly, how the Americans are making so many of them." Over the next 3 weeks, those German mechanics would take apart the M3 half-track bolt by bolt. And what they discovered would shake their understanding of modern warfare to its core. This is not a story about raw horsepower or thick armor. This is a story about a fundamental clash of philosophies. German engineering versus American industrial pragmatism. Perfection versus production. Craftsmanship versus mass manufacture. And in that dusty North African depot, German mechanics were about to learn a lesson that their high command desperately needed to understand but refused to accept. The M3 half-track wasn't just a vehicle. It was a statement. A rolling embodiment of American industrial might. And the Germans who tore it apart piece by piece came to a terrifying realization. Germany was fighting the wrong kind of war. They were trying to out-engineer an enemy that had already moved past engineering as the primary weapon. The Americans had weaponized their factories. They had turned assembly lines into artillery. And vehicles like the M3 half-track were the proof. By the time those German mechanics finished their evaluation and wrote their reports, their mockery had turned to grudging respect. Then to concern. And finally, for some, to a creeping dread about what this simple, crude vehicle really meant for Germany's chances in this war. The Americans had built a machine that could be produced faster than Germany could destroy them. A vehicle that any soldier could maintain. A workhorse that prioritized reliability over refinement. And they had built 41,000 of them. This is the story of what happened when German engineering excellence met American industrial reality. When precision craftsmanship confronted mass production. When the old way of making war collided head-on with the new. This is the story of the day German mechanics learned that sometimes, good enough in massive quantities beats perfect in limited numbers. And it all started with one captured half-track in the desert. The story of how this particular M3 half-track fell into German hands begins on December 3, 1942, during the desperate fighting around Tobruk, Tunisia. The Americans had just arrived in North Africa as part of Operation Torch. They were green, untested, and they were about to receive a brutal education from Erwin Rommel's Afrika Korps. The battle for Tobruk was chaos. American units, many seeing combat for the first time, were hit hard by experienced German panzer and infantry formations. In the confusion of a fighting withdrawal, a mechanized infantry platoon from the 1st Armored Division was forced to abandon several vehicles, including 3 M3 half-tracks. 2 of the half-tracks were destroyed by their crews before retreating. Standard procedure. Disable the vehicle, remove the weapons, get out. But the third half-track, vehicle number 403-1128, had stalled in a wadi. Under heavy fire, with German machine guns raking the position, the crew bailed out and ran. They didn't have time for proper demolition procedures. They assumed the Germans would destroy it anyway, or that American forces would recover it when they counterattacked. They were wrong on both counts. Lieutenant Klaus Richter, commanding a reconnaissance unit from the 10th Panzer Division, found the half-track less than an hour later. His men approached cautiously, weapons ready, expecting booby traps. But the vehicle sat there intact. The engine was cold. The 50 caliber machine gun had been removed from its mount, but otherwise, the half-track was in perfect condition. Richter radioed his company commander immediately. This wasn't just another abandoned vehicle. This was intelligence gold. German forces had encountered American half-tracks in combat before, but always at a distance or as burning wrecks. Getting one intact and operational was rare. Richter knew that somewhere up the chain of command, people would want to examine this vehicle very carefully. Within 2 hours, a recovery team arrived. They hooked the half-track to a German half-track recovery vehicle and towed it back to a collection point. From there, it began a journey that would take it through 3 different evaluation sites. First stop was a forward maintenance company, where combat engineers gave it a quick once-over. They checked for explosives, documented its condition, and took photographs. The engineers were surprised by what they found. The vehicle had over 8,000 kilometers on the odometer. It had clearly seen hard use, but mechanically, it appeared sound. The stalling issue was simple. It had run out of fuel. After refueling with captured American gasoline, the half-track started on the first attempt. That got people's attention. The vehicle was then sent to a corps-level maintenance depot near Bizerta, where more specialized mechanics examined it. They spent several days testing it, driving it, putting it through its paces. The reports they filed were detailed and, notably, impressed. But the real evaluation would happen at the third location, a special technical intelligence facility outside Tunis. This was where captured Allied equipment was systematically analyzed by Germany's best automotive engineers and military technical experts. The M3 half-track arrived there in late December 1942, transported on a heavy truck to prevent adding more kilometers to the odometer. The Germans wanted to examine it in as close to original condition as possible. Hauptmann Friedrich Weber was waiting for it. Weber was a pre-war automotive engineer from Stuttgart who had worked for Daimler-Benz before the war. He had evaluated dozens of captured vehicles, British trucks, American jeeps, Soviet tanks. He had a reputation for thorough, unbiased technical assessments. Weber's team consisted of 6 mechanics, 2 engineers, and a technical illustrator who would document everything with detailed drawings. They had orders from the highest levels. Understand everything about this vehicle. How it's built. How it performs. How the Americans are producing so many of them. The evaluation order came directly from Albert Speer's Armaments Ministry. Speer, Hitler's Minister of Armaments and War Production, was desperately trying to understand how the Allies, particularly the Americans, were outproducing Germany so dramatically. Every piece of captured equipment was a window into enemy manufacturing capabilities. When Weber first laid eyes on the M3 half-track, his reaction was different from his mechanics. While they saw a crude, utilitarian vehicle, Weber saw something else. He saw design choices, compromises, priorities. He walked around it slowly, notebook in hand, jotting observations. The body was mostly flat steel panels. Riveted and bolted construction, not welded. Minimal curves or complex shapes. The tracks used rubber pads. The wheels were standard truck wheels. Everything about the design screamed mass production. Weber turned to his team and said something that surprised them. This vehicle was designed to be built by the millions. Not by skilled craftsmen, but by factory workers. Possibly even women and unskilled labor. Everything about it is deliberate. Let's find out if it actually works. The mechanics exchanged glances. The idea that something designed for mass production by unskilled workers could possibly match German engineering quality seemed absurd. They were about to learn otherwise. Weber ordered the half-track moved into the main workshop bay. Arc lights were positioned around it. Tools were laid out. Measurement devices prepared. Cameras loaded with film. "Gentlemen," Weber announced, "begin the teardown. And document everything. Everything." The evaluation had begun. Before the first wrench was turned, Hauptmann Weber gathered his team for what he called a visual assessment session. This was standard procedure. Look at the vehicle. Form hypotheses. Make predictions. Then test those predictions against reality. The 6 mechanics stood around the M3 half-track with clipboards, taking notes as Weber called out observations. "First impression, construction quality," Weber said, running his hand along the vehicle's side panels. "What do we see?" Oberstfreiter Müller spoke up immediately. "Crude workmanship, sir. Look at these rivets. They're functional, but there's no precision. No finesse. Some are slightly misaligned. On a German vehicle, this would be unacceptable." Another mechanic, Feldwebel Ernst Hoffmann, pointed to the hood. "The panel gaps are inconsistent, Herr Hauptmann. Some places have 3 millimeters of clearance, others have 6 or 7. Variable quality control." Weber nodded, writing this down. "What else?" "The paint is thin," offered a third mechanic. "You can see primer showing through in several places. Rushed application. Poor surface preparation." These observations weren't wrong. The M3 half-track sitting in their workshop did have uneven rivet spacing. The panel gaps were inconsistent. The paint was thin. By German standards of precision manufacturing, the vehicle looked like it had been thrown together by workers who didn't particularly care about the details. But Weber was already noticing something else. Something his mechanics would understand soon enough. Every single one of those flaws they had identified, none of them affected the vehicle's function. The rivets held. The panels protected. The paint prevented rust. The vehicle worked despite not being perfect. Weber moved to the front of the half-track and pointed at the hood. "Design simplicity. Observations." "It's very basic, sir," Müller said. "The hood is just a few flat steel panels. Our Sd.Kfz 251 has a much more sophisticated front end. Better aerodynamics. More refined lines." Hoffmann added, "The entire body is made from flat or gently curved panels. No compound curves. No stamped structural elements of complexity. It's like they designed it to be built by people who barely know how to use metalworking equipment." Again, the observation was accurate. But Hoffmann hadn't yet grasped that this was intentional. Flat panels could be cut and formed quickly. Simple shapes meant simpler dies and presses. Fewer compound curves meant less skilled labor required. Weber asked his team to estimate production time. "Based on what you see, how long do you think it takes to build one of these vehicles?" The mechanics conferred briefly. Müller offered an estimate. "Given the crude construction and simple design, perhaps 2 to 3 weeks per vehicle, sir. Maybe faster if they're truly sacrificing quality for speed." Weber smiled slightly. He had seen intelligence reports. The real number would shock them, but he wanted them to discover it themselves through their analysis. "Now, let's compare it to what we know," Weber said, gesturing to a corner of the workshop where a damaged Sd.Kfz 251 sat waiting for repairs. "Our half-track versus theirs. What are the obvious differences?" The comparison was striking. The German Sd.Kfz 251 was, by any aesthetic measure, a more beautiful vehicle. Its armored body featured complex angles designed for maximum ballistic protection. The front end had a sophisticated sloped design. The construction was precise, with tight tolerances and careful welding. Every panel fit perfectly. The overall impression was one of careful engineering and skilled craftsmanship. The American M3, by contrast, looked utilitarian. boxy, simple, almost agricultural in its design philosophy. The Sd.Kfz 251 is clearly the superior design, Hoffman stated confidently. Better protection, more sophisticated armor arrangement, professional construction quality. This American vehicle looks like a farm tractor with tracks bolted to it. Several mechanics chuckled at this observation. Weber let them have their moment. Then he asked a different question. How many Sd.Kfz 251s has Germany produced since the start of the war? Muller thought for a moment. I'm not certain of exact figures, sir, but several thousand certainly. They're common enough that most mechanized units have them. According to the latest production reports I've seen, Weber said carefully, we've produced approximately 7,000 Sd.Kfz 251s since 1939. Impressive, yes. The mechanics nodded. 7,000 vehicles in 3 years. A substantial production achievement. Weber paused, then continued. Intelligence estimates that the Americans have already produced more than 15,000 of these M3 half-tracks. And they only started manufacturing them in 1941. Less than 2 years ago. Silence fell over the workshop. 15,000 vehicles in less than 2 years versus 7,000 in 3 years. The math was simple and disturbing. But surely, sir, Muller protested, those numbers must include inferior vehicles. Perhaps training models. Non-combat versions. The Americans couldn't possibly be producing 15,000 combat-capable vehicles. Weber shook his head. The intelligence is clear. These are fully militarized vehicles. Combat-ready. And the Americans are still accelerating production. Current estimates suggest they'll produce another 20,000 or more before the war ends. Hoffman stepped closer to the M3, looking at it with new eyes. How is that possible? The complexity alone, the skilled labor required. That, Weber said, is exactly what we're here to discover. This vehicle is simple for a reason. It's crude for a reason. Every design choice, every compromise, every deviation from our standards of engineering excellence serves a purpose. And that purpose is mass production at a scale we've never attempted. He walked around the half-track slowly, pointing out features as he spoke. Look at this vehicle not as engineers who value perfection, but as factory managers who need to build thousands of units per month. Every rivet that's misaligned, that's a rivet installed quickly by a worker who doesn't need precision training. Every panel gap that's inconsistent, that's a panel that doesn't require hours of fitting and adjustment. Every flat surface instead of a compound curve, that's a piece that can be stamped out in seconds rather than hand-formed over hours. The mechanics were beginning to understand. The Americans aren't trying to build the best half-track, Weber concluded. They're trying to build a good enough half-track in quantities that overwhelm us. And gentlemen, I suspect they've succeeded. Our job is to understand how and to determine if there's anything we can learn or counter. Muller looked at the M3 with a new expression. Not mockery. Something closer to concern. When do we begin the detailed teardown, Herr Hauptmann? Right now, Weber replied. Start with the engine. I want to know what makes this crude vehicle run. The real education was about to begin. The next morning, the workshop bay smelled of oil and metal as the mechanics prepared to remove the M3's engine. This was the moment of truth. The engine was the heart of any military vehicle. If the Americans had cut corners here, it would show immediately. Oberstfreiter Muller and Feldwebel Hoffman worked together to disconnect the engine mounts, fuel lines, and electrical connections. The process took less than 2 hours. That fact alone was noteworthy. Herr Hauptmann, Muller called out, the engine access is remarkable. Everything is easily reached. On our Sd.Kfz 251, removing the engine is a 6-hour job minimum. This took us less than 2. Weber nodded, making notes. Ease of maintenance. Continue. Using a chain hoist, they lifted the engine out of the chassis and set it on a heavy workbench. There it sat, the white 160AX engine. An inline six-cylinder gasoline engine displacing 386 cubic inches, rated at 147 horsepower at 3,000 revolutions per minute. The German mechanics gathered around it like surgeons examining a patient. At first glance, the white 160AX looked almost comically simple compared to German military engines. There were no exotic alloys visible, no intricate castings, no evidence of advanced metallurgical techniques. It was, to their eyes, a straightforward truck engine adapted for military use. It's a commercial design, Hoffman observed, pointing to various features. This is essentially a heavy-duty truck engine. Look at the cylinder block. Simple cast iron. The cylinder head is aluminum, which is good for weight, but the overall design is at least 10 years old. Maybe older. Muller examined the engine mounts. The mounting system is crude but effective. Rubber isolators. Very simple. Our engines use more sophisticated mounts to reduce vibration. Weber asked them to begin the internal examination. Over the next several days, they would completely disassemble the engine, measuring tolerances, examining wear patterns, and analyzing every component. What they discovered surprised them. The engine's internal components showed a design philosophy fundamentally different from German practice. Where German engineers pursued precision and performance, American engineers had pursued reliability and maintainability. The pistons, for example, were slightly heavier than optimal for maximum performance. But they were also more durable. The tolerances were looser than German standards would permit, but this actually helped. Looser tolerances meant the engine could run with more dirt and debris in the oil without seizing. It meant parts could be manufactured faster and still function. The connecting rods were overbuilt, thicker and heavier than necessary for the power output. This cost some performance, but it meant they almost never failed, even under severe abuse. Hoffman spent an entire day examining the crankshaft. He ran his fingers along the journals, checking for wear. After over 8,000 kilometers of operation, including combat conditions and African desert dust, the wear was minimal. "Sir, this crankshaft shows remarkably even wear," Hoffman reported to Weber. "The bearing surfaces are in excellent condition. The metallurgy is not sophisticated, but it's effective. This engine could easily run another 8,000 kilometers without major service." Weber examined it himself. Hoffman was right. The crankshaft wasn't made from exotic steel alloys. It wasn't precision ground to impossibly tight tolerances. But it worked, and it lasted. The camshaft told a similar story. Simple design. Conservative cam profiles for durability rather than maximum power. But the lobes showed minimal wear, and the timing gear was barely marked despite thousands of kilometers of operation. Muller focused on the valve train. The valves are simple mushroom-type valves. Nothing exotic. But look at this. He pointed to the valve guides. Almost no wear. The valve seats are barely marked. Whoever designed this chose materials and designs that last. The cooling system examination was equally revealing. The radiator was overbuilt for the engine's heat output. This made the vehicle slightly heavier and took up more space, but it meant the engine ran cooler and had a massive reserve capacity. In the brutal heat of North Africa, this was invaluable. The water pump was simple, almost primitive by German standards. But it was also nearly impossible to break. Large, robust bearings. A simple impeller design. No precision parts that could fail. Everything is over-engineered for durability, Weber summarized in his notes. The Americans have sacrificed performance for reliability. But in doing so, they've created an engine that can be maintained by minimally trained personnel and can survive conditions that would destroy more sophisticated designs. The oil filtration system particularly impressed the German engineers. The M3 used a full-flow oil filter, a relatively advanced feature for the time. The filter element was simple and cheap to replace, but it kept the oil remarkably clean. Even after 8,000 kilometers in the desert, the internal engine components showed minimal wear. Then came the revelation that truly shocked them: production analysis. Weber had obtained documentation from intelligence sources about American engine manufacturing. He shared these details with his team as they reassembled the engine to test it. This White 160AX engine, Weber explained, is produced at a rate of approximately one engine every 45 minutes in their factories. One engine. 45 minutes. Start to finish. The mechanics stared at him in disbelief. "That's impossible, sir," Muller protested. "An engine this size, with this complexity. Our Maybach engines for the Sd.Kfz 251 take days to assemble. Even working around the clock, we can't approach those numbers." Weber showed them photographs that intelligence had obtained of American engine production lines. The images showed something the Germans had never attempted: true assembly line production of military engines. Rows of engines moving along conveyor systems. Workers at individual stations, each performing one specific task. No single worker assembled an entire engine. Instead, each worker did the same job over and over, becoming incredibly fast and efficient at that single task. One worker installed pistons. Another installed the cylinder head. Another connected fuel lines. Each task took minutes, and the engine moved continuously down the line. "They've applied automobile production techniques to military equipment," Weber explained. "Henry Ford's assembly line methods, adapted for war production. Each worker needs minimal training because they only do one job. The engines aren't hand-built by master mechanics. They're assembled by factory workers who might have been farmers or shopkeepers months earlier." Hoffman looked troubled. "But sir, without skilled craftsmen, how can they maintain quality?" Weber pointed to the disassembled engine components laid out on the bench. "By designing for simplicity and tolerance. Look at these parts. Almost nothing requires precision fitting. Everything is designed with enough clearance that dimensional variations don't matter. Parts are interchangeable. Any piston fits any cylinder. Any connecting rod works in any position." He picked up a piston. "This piston came from an engine built in America months ago. But I could take a piston from any other White 160AX engine, and it would fit perfectly. True interchangeability. We talk about this concept, but the Americans have actually achieved it at massive scale." The team spent 2 more days testing the reassembled engine. They ran it at various speeds, under load, checking temperatures and pressures. The engine performed flawlessly. It didn't produce the peak horsepower of comparable German engines. It wasn't as smooth or refined. But it ran and ran and ran. It tolerated poor quality fuel. It handled extreme temperatures. It forgave operator errors that would destroy a more sophisticated engine. On the 3rd day of testing, Weber had them deliberately abuse the engine. They ran it low on oil. They pushed it past redline. They fed it contaminated fuel. The engine kept running. "It's almost impossible to kill," Muller admitted grudgingly. "I've been trying to make it fail, and it just keeps working." Weber made final notes in his report. "The American approach is revolutionary," he wrote. "They have abandoned the pursuit of engineering excellence in favor of engineering adequacy at scale. The White 160AX is not the best engine we've examined. But it is good enough, and they can produce it in quantities we cannot match." He paused, then added a sentence that would appear in bold in his final report: 1,000 adequate engines will win more battles than 100 excellent engines. The engine examination was complete. But it was just the beginning of what the Germans would learn from this captured half-track. With the engine analysis complete, Hauptmann Weber's team turned their attention to what made the M3 truly unique: its half-track system. This was the feature that gave the vehicle its name and its capability. The combination of front wheels and rear tracks was not new. Germany had been building half-tracks since the 1930s. But as the mechanics began examining the American approach, They quickly realized that the M3's track system was fundamentally different from anything they had seen before. Feldwebel Hoffmann was assigned to lead the suspension analysis. He started by jacking up the rear of the vehicle and removing one of the track assemblies. As the track came off, something immediately caught his attention. "Herr Hauptmann, look at this," Hoffmann called out, running his hand along the track. "Rubber pads. The entire ground contact surface is rubber." Weber came over to examine it. The M3's tracks featured thick rubber pads bonded to the metal track links. This was highly unusual. German half-tracks used all-metal tracks. So did most tracked vehicles. Why would they do this? Muller wondered aloud. Rubber wears faster than steel. It's more expensive. It seems like an unnecessary complication. Weber crouched down, examining the track more closely. "Test it," he ordered. "Drive the vehicle on different surfaces. Measure traction, noise levels, vibration. Let's understand what advantage this gives them." Over the next week, the Germans put the M3 through extensive mobility trials. They drove it on paved roads, dirt tracks, sand, and rocky terrain. They measured everything: speed, fuel consumption, track wear, crew comfort, and noise signature. The results were eye-opening. On paved roads, the rubber-padded tracks transformed the M3's characteristics entirely. Where German half-tracks with metal tracks chewed up road surfaces and created deafening noise, the M3 ran almost quietly. The rubber pads gripped the pavement smoothly, and the ride inside was remarkably comfortable. Hoffmann rode in the vehicle during road tests and returned with a surprised expression. "Sir, at 40 km per hour on pavement, the vibration is less than our Sd.Kfz 251 at half that speed. You can actually have a conversation inside without shouting. The rubber absorbs the impacts." But the real revelation came during cross-country tests. The German half-tracks used a complex suspension system called the Schachtel-Laufwerk, or interleaved road wheel arrangement. The wheels overlapped each other in a sophisticated pattern that provided excellent weight distribution and a smooth ride. It was an engineering masterpiece. But it had problems. The M3 used a much simpler system, the vertical volute spring suspension. Each road wheel was mounted on a simple trailing arm with a large coil spring. No interleaving. No complexity. Just 8 independent wheels on simple, robust mounts. At first glance, this looked primitive compared to the German system. But in actual use, the advantages became clear. Muller spent 2 days examining the suspension components. What he found troubled him, because it revealed yet another example of American practical thinking versus German engineering sophistication. "The suspension is remarkably simple," Muller reported to Weber. "Each road wheel assembly is identical. Completely interchangeable. There are no left or right specific parts. If a wheel or spring is damaged, you unbolt it and bolt on a new one. 10 minutes. Maybe 15 for an inexperienced crew." He contrasted this with their own Sd.Kfz 251. "Our interleaved suspension is superior in ride quality on smooth terrain, but if you damage one wheel, you often have to remove 3 or 4 others to access it. In combat conditions, this can take hours. And in mud or snow, the entire system becomes a liability." Weber asked for clarification. "Explain the mud problem." Hoffmann demonstrated using a model. "Our interleaved wheels are closely spaced. When you drive through mud, it packs into the spaces between the wheels. In cold weather, this mud freezes solid overnight. In the morning, the vehicle is immobilized. The crews have to literally build fires under the tracks to thaw them out. This can take hours." He pointed to the M3's suspension. "Their wheels are widely spaced. Mud and debris fall through naturally. Nothing packs in. Even if snow or ice does accumulate, each wheel can be accessed independently and cleared quickly." The team conducted a brutal test. They drove the M3 through a muddy wadi, then let it sit overnight. The temperature dropped near freezing. In the morning, while a German Sd. Sd.Kfz 251 in the same conditions would have been frozen solid. The M3 started up and drove away after only a few minutes of the crew kicking ice off the simple, accessible suspension components. The track tension system provided another lesson in American design philosophy. German tracks required careful adjustment of tension. Too loose, and they could throw a track. Too tight, and they wore prematurely. Proper adjustment required experienced mechanics and specialized tools. The M3's track tension system was almost foolishly simple. A single large nut on a threaded rod. Any soldier with a wrench could adjust it in minutes. No special tools. No expertise required. They've designed this vehicle assuming their crews are not expert mechanics, Weber observed. Everything is simple enough for a barely trained operator to handle. The team measured track life. The rubber pads showed wear after the vehicle's 8,000 kilometers of use, but they were far from worn out. Intelligence reports suggested the tracks typically lasted 15,000 to 20,000 kilometers before requiring replacement. More importantly, replacing worn pads was simple. The pads were bolted on. In the field, crews could replace individual worn pads without replacing the entire track. German metal tracks required complete track replacement when worn. The front wheel system also revealed clever thinking. The M3 used standard military truck wheels and tires on the front. This meant that parts were interchangeable with thousands of other American vehicles. Tires, wheels, hubs, bearings, all standard components. German half-tracks used specialized front wheels, unique to the vehicle type. If you needed a replacement, it had to come from a specialized supply chain. Muller calculated the logistics implications. Sir, if an American mechanized unit needs replacement wheels for their half-tracks, those wheels can come from supply trucks, cargo trucks, or any number of other vehicles. They share common parts across their entire fleet. Our vehicles each require unique components. Weber was beginning to see a pattern. Every design choice in the M3 half-track prioritized logistics, maintainability, and mass production over pure performance or engineering elegance. The Germans tested the M3's cross-country performance against their own vehicles. The results were humbling. In soft sand, the M3 performed admirably. The wide tracks and relatively light weight gave it good flotation. It wasn't as good as a fully tracked vehicle, but it was far better than a wheeled truck. In mud, the simple suspension and widely spaced wheels proved superior to the German interleaved system. The M3 powered through conditions that would have bogged down an Sd.Kfz 251 until its tracks could be cleared. On rough terrain, the M3's suspension absorbed punishment that would have damaged more delicate systems. Hoffmann deliberately drove it over obstacles that would normally require careful navigation. The half-track bounced and crashed but kept going. Nothing broke. It's not sophisticated, Hoffmann admitted in his report, but it's nearly indestructible. And that may be more valuable than sophistication. The speed tests provided final confirmation of the American approach. On roads, the M3 could cruise comfortably at 55 km per hour. On decent off-road terrain, it maintained 30 to 35 km per hour. Not exceptional, but consistent and reliable. The German Sd.Kfz 251 could achieve similar speeds, but only when in perfect mechanical condition and operated by experienced drivers. The M3 delivered its performance regardless of operator skill or maintenance state. Weber's final notes on the suspension system were telling. The Americans have created a suspension system that sacrifices ultimate capability for consistent, reliable performance. It is not the best suspension we have examined, but it is good enough for all normal conditions, and it can be maintained and repaired by soldiers with minimal training. Once again, we see the same philosophy. Adequate performance at massive scale defeats excellent performance in limited numbers. He added one more observation that would prove prophetic. Our Sd.Kfz 251 is a better vehicle than the M3 half-track in many measurable ways. But the Americans will build 5 M3s for every Sd.Kfz 251 we produce. And in war, quantity has a quality all its own. The suspension analysis was complete. But the deeper lesson was becoming impossible to ignore. The Americans weren't trying to beat Germany at engineering. They were changing the rules of the game entirely. On the 8th day of the evaluation, Hauptmann Weber received a package from Berlin. Inside were photographs, documents, and intelligence reports about American manufacturing facilities. What he read kept him awake that night. The next morning, he called his entire team together for what he described as the most important part of our analysis. "Gentlemen," Weber began, spreading photographs across a large table, "we've been examining this vehicle as engineers. Now we need to examine it as it was truly designed, as a product of industrial warfare." The photographs showed American factories, massive buildings, assembly lines stretching hundreds of meters, rows of partially completed half-tracks moving through production stations, and thousands upon thousands of workers. Weber pointed to one photograph showing the White Motor Company plant in Cleveland, Ohio. This single factory produces approximately 100 half-tracks per week. One factory. 100 vehicles. Every week. The mechanics stared at the numbers, trying to comprehend the scale. Muller spoke first. "Sir, that's impossible. The complexity of coordinating that many workers, that many parts, that many vehicles." "It's not only possible, it's happening," Weber interrupted. "And it's happening at multiple factories simultaneously. White Motor Company, Autocar, Diamond T, International Harvester, all building the same vehicle to the same specifications." He pulled out another document. "This is where we must understand what we're truly facing. Let me show you how the Americans are doing this." Weber walked over to the partially disassembled M3 and placed his hand on the hull. "Look at this vehicle with new eyes. Not as a machine, but as an assembly of standardized components designed for rapid production." Feldwebel Hoffmann moved closer, studying the hull structure. "Notice the body panels," Weber continued. "Every single panel is flat or uses only simple curves. Why? Because flat panels can be stamped out by the thousands with simple dies. No hand forming. No skilled metalworkers needed. A worker with 1 week of training can operate a stamping press and produce perfect panels all day long." He pointed to the rivets holding the panels together. "Why rivets instead of welding? Because riveting can be done by semi-skilled workers. It's fast. It's consistent. And it's easy to inspect. A riveted joint is either good or it's obvious it's bad. Welding requires skilled craftsmen who take years to train." Muller examined the rivet pattern more closely. He had initially dismissed it as crude work. Now he saw it differently. Every rivet was functional. The spacing was consistent enough to provide strength. The pattern was simple enough that workers could follow it without complex blueprints. "The entire vehicle is designed around the capabilities of average factory workers," Weber explained. "Not master craftsmen. Not skilled metal workers. Just ordinary people who can be trained quickly." He showed them a document detailing the American approach to parts standardization. Every M3 half-track uses the same components. A door latch from vehicle number 1 will fit perfectly on vehicle number 1000. This is true interchangeability, achieved through careful design and controlled manufacturing tolerances. Weber contrasted this with German production. "Our Sd.Kfz 251 requires skilled fitters to adjust and modify parts during assembly. Almost nothing is truly interchangeable. Each vehicle is slightly different because we allow skilled workers to make judgment calls during construction. This produces good vehicles, but it's slow and requires expertise we don't have enough of." The intelligence reports contained even more revealing information. Weber shared details about American production planning that shocked his team. "The Americans break down the entire vehicle into subassemblies," he explained. "The engine is built at one factory. The transmission at another. The axles at a third location. The body panels are stamped at multiple facilities. Everything comes together at final assembly plants." He showed them a flow chart of the production process. This allows them to use existing manufacturing capacity across their entire industrial base. They're not building new factories from scratch. They're adapting existing automotive, truck, and agricultural equipment plants to military production. Muller studied the chart. This is Henry Ford's assembly line concept, extended across an entire nation. Exactly, Weber confirmed. Ford revolutionized automobile production with moving assembly lines and interchangeable parts. The Americans have applied those same principles to military equipment. And it's devastatingly effective. The team spent the afternoon examining every fastener, bracket, and component on the M3, looking for evidence of this production philosophy. They found it everywhere. The electrical system used simple, color-coded wiring. No complex diagrams needed. Any electrician could trace and repair it. The wire gauge was standardized, only 3 different sizes used throughout the entire vehicle. This simplified inventory and training. The fuel system used standard pipe fittings. Off-the-shelf components. Nothing custom-made. If something broke, replacement parts were available from civilian suppliers. Even the seats were designed for production efficiency. Simple tubular steel frames with canvas cushions. No upholstery work required. No skilled craftsman needed. A worker with basic welding skills could make the frames. Another worker could sew the canvas covers on a standard sewing machine. Every single choice prioritizes speed of production, Hoffman observed. Nothing is made more complex than absolutely necessary. Weber nodded. And this is what we must understand. The Americans aren't trying to build the best possible half-track. They're trying to build an acceptable half-track in numbers that overwhelm any opponent. He pulled out production figures that intelligence had compiled. Germany has produced approximately 7,000 Sd.Kfz 251 half-tracks since 1939. This represents a tremendous industrial effort. Our factories, our workers, our resources have gone into these vehicles. Weber paused for effect. The Americans began producing the M3 in 1941. In less than 2 years, they've produced over 15,000. And production is still accelerating. Intelligence estimates they'll produce 40,000 or more before the war ends. The silence in the workshop was profound. How many man-hours to build one Sd.Kfz 251? Weber asked. Muller knew these figures. Approximately 2,000 man-hours, sir. From raw materials to finished vehicle. The M3 half-track requires approximately 1,000 man-hours, Weber stated. Half the time. And because of their assembly line methods, much of that work can be done by semi-skilled or even unskilled workers with minimal training. He showed them photographs of American factory workers. Many were women. Many appeared young or elderly. These were not experienced industrial workers. These were ordinary Americans who had been given a few weeks of training and put to work. This is what we're facing, Weber said quietly. They've turned their entire society into a war production machine. Farmers, shopkeepers, housewives, all building weapons. And the weapons are designed specifically so that these ordinary people can build them. Hoffman examined the M3's construction with renewed understanding. Every design choice makes sense now. The simple panels. The riveted construction. The standardized parts. The accessible maintenance points. It's all deliberate. Yes, Weber agreed. And it's brilliant in its own way. Not elegant. Not sophisticated. But perfectly adapted to its purpose. Mass production for industrial warfare. The team discussed the cost implications. The M3 half-track wasn't cheap to build, but it was far less expensive than a Sd.Kfz 251. Simpler construction meant less material. Standardized parts meant cheaper manufacturing. Assembly line methods meant lower labor costs. Weber shared one final piece of intelligence that summarized the challenge Germany faced. Albert Speer's ministry has calculated that if we attempted to match American half-track production, we would need to divert approximately 30% of our entire industrial capacity. 30%. And we would need to completely retool our manufacturing methods, which would take years. He let that sink in. The Americans didn't just design a vehicle. They designed an entire production system. The vehicle itself is almost secondary to the manufacturing process that creates it. Muller looked at the M3 with something approaching respect. We've been fighting the wrong war. We're trying to out-engineer them. But they're not playing an engineering game. They're playing a production game. Exactly, Weber said. And in a production game, good enough in massive quantities defeats perfect in limited numbers every single time. He began writing his report summary. The M3 half-track represents a paradigm shift in military vehicle design. It is not designed to be the best vehicle possible. It is designed to be good enough while being producible in quantities that enemy forces cannot match regardless of their technical sophistication. Weber added a final note that would be highlighted in red when his report reached Berlin. Germany cannot win a production war against the United States. Our only hope is to win quickly, before American industrial capacity reaches full mobilization. Every month that passes without German victory makes American numerical superiority more insurmountable. The production analysis was complete. And the message was clear and terrifying. Germany was in a race it couldn't win. With the M3's mechanical secrets being laid bare, Hauptmann Weber assigned a small team to analyze the vehicle's interior. This was the human element. The space where soldiers lived, fought, and sometimes died. Here too, the German evaluators found a design philosophy that was both alien and disturbingly effective. Their own Sd.Kfz 251 was designed from the outside in. Its complex, sloped armor plates dictated the shape of the interior, resulting in a relatively cramped and angular crew compartment. For the Panzer Grenadiers packed inside, it was a functional but tight space. Getting in and out, especially under fire with full gear, was a practiced maneuver. The American M3, by contrast, felt as though it had been designed from the inside out. Its simple, boxy hull created an interior that was remarkably spacious and uncluttered. There is no wasted volume on complex armor angles, one of the junior engineers noted in his report. The entire space is dedicated to the crew and their equipment. The layout was a model of utilitarian logic. Simple bench seats ran along the sides, providing enough room for a full 10-man rifle squad to sit without being crammed together. More importantly, access was through a large, wide door at the rear. The Germans timed it. A full squad could exit the M3 in less than 5 seconds. From their own cramped 251, a similar exit under pressure could take twice as long. The driver's compartment was another revelation. The dashboard and controls were almost identical to a standard American commercial truck. The gauges were large, simple, and clearly labeled. Any American who can drive a farm truck can operate this vehicle with an hour of training, Feldwebel-Hoffmann remarked. This was a deliberate choice, designed to draw from a massive pool of already skilled drivers and slash training times. The team also cataloged the numerous small, thoughtful features designed to improve the crew's life in the field. There were stowage racks for rifles, ammunition boxes, water cans, and personal gear. They found the standard-issue canvas cover, a simple but effective piece of equipment that could be erected over the compartment to protect the crew from the searing desert sun or freezing rain. At first, the German mechanics viewed these features with a degree of condescension. It seemed like the Americans were building a mobile hotel room, not a weapon of war. But Weber corrected their thinking. This is not about comfort, he explained. This is about combat effectiveness. A soldier who is exhausted from the sun, soaked from the rain, and cramped for hours is not an effective soldier. The Americans understand this. They are preserving the fighting strength of their men. The conclusion was clear. The Sd.Kfz 251 was a superb armored vehicle that carried troops. The M3 half-track was a superb troop carrier that happened to have armor. It was a subtle but profound difference in priority. The M3 was a tool, designed around the needs of its user. and while it lacked the sophisticated protection of its German counterpart, it delivered its human cargo to the battle line in better condition to fight. For Obergefreiter Müller and the other veteran mechanics, the most humbling phase of the evaluation was the analysis of the M3's maintenance and repair philosophy. These were men who defined their professional worth by their ability to tame complex machinery. The M3, they discovered, was designed to make their level of expertise almost unnecessary. The principle of accessibility was everywhere. On the Sd.Kfz 251, a simple task like servicing an inner road wheel could take half a day, requiring the removal of multiple other wheels just to get to the damaged one. On the M3, the entire suspension bogie was a self-contained unit bolted to the outside of the hull. Muller's team, as a test, removed and replaced a complete bogie assembly in under 30 minutes using only the tools found in the vehicle's own kit. That toolkit was the next item of study. It was shockingly basic, a set of standard-sized wrenches, sockets, a hammer, and screwdrivers. There were no specialized tools, no complex diagnostic equipment. Accompanying it was a technical manual. Weber, who spoke fluent English, read passages aloud. The language was simple, direct, and filled with clear diagrams. "This is written for a farmer, not a mechanic," Hoffman stated, and he was not wrong. This was the core of what the Germans began to call the soldier-proof design. The M3 was built on the assumption that it would be operated and maintained by draftees with only a few weeks of training. It was designed to forgive abuse. The robust engine could tolerate poor fuel. The simple suspension could be repaired with brute force and basic tools. The standardized parts meant a soldier didn't need to find a specific component for a specific vehicle. Weber tasked two of his junior mechanics with a timed experiment. He gave them the American manual and toolkit and instructed them to perform 3 common field repairs: change the engine oil and filters, replace a damaged front wheel, and adjust the track tension. They completed all 3 tasks in just over an hour. The equivalent work on an Sd.Kfz 251 would have been a half-day job for an experienced team. The final report submitted by Weber's team contained a section on serviceability that served as a stark warning to the high command. One passage was particularly damning. The American vehicle is engineered not for optimal performance, but for optimal availability. Its primary design virtue is its simplicity. Major components can be replaced in the field by crews with moderate training, whereas our equivalent vehicle requires the attention of specialists. In a prolonged conflict, the operational readiness of American mechanized units will, by design, be consistently higher than our own. The message was unmistakable. The Americans had designed a vehicle that was built to fight, not to sit in a workshop waiting for a master mechanic. While the engineers focused on the how, military analysts in Tunis were focused on the why. How did this simple, mass-produced vehicle actually perform in combat? Their analysis, combined with battlefield reports, revealed that the M3's greatest strength was not in any single attribute, but in its incredible versatility. The Sd.Kfz 251 was also a versatile platform, but the M3's simple, truck-like chassis made it an even better universal carrier. American industry had spawned an entire family of vehicles from the basic M3 design. The Germans studied the intelligence reports with growing alarm. There was the M3 gun motor carriage, which mounted a 75mm cannon, turning the transport into a potent, if lightly armored, tank destroyer. There was the M4 mortar carrier. There were multiple anti-aircraft versions, armed with everything from .50 caliber machine guns to 37mm cannons. It could be a command vehicle, a radio relay, an ambulance, or an artillery tractor. This modularity, built upon a single standardized chassis, was a logistical masterpiece. It meant American divisions could perform dozens of different battlefield roles using a vehicle that shared the same engine, transmission, and suspension parts. It was a nightmare for the German quartermasters, but a dream for the Allies. When it came to armor, the analysts confirmed the mechanics' initial assessment: the M3 was vulnerable. Its maximum armor thickness was only 12.7 millimeters, half an inch, and it was not sloped. It could stop rifle-caliber bullets and shell fragments, but it offered almost no protection against German anti-tank rifles, let alone the shells from a panzer. However, the Americans knew this. Their doctrine did not call for the M3 to be used as a frontline assault vehicle. The M3 was a battle taxi. Its job was to use its speed and reliability to get infantry to the edge of the battle, where they would dismount and fight on foot. Its powerful .50 caliber Browning machine gun provided excellent fire support against infantry and light vehicles, but it was expected to avoid duels with German armor. In this specific role, its performance was excellent. Its mechanical reliability meant that more vehicles were available for any given operation. Its speed on roads allowed American commanders to exploit breakthroughs and move reserves around the battlefield with a speed that often surprised the Germans. While an individual M3 was an easy kill for a panzer, the vehicle was rarely found alone. They moved in groups, supported by tanks and artillery, as part of a combined arms system. Its effectiveness wasn't measured by how it performed in a one-on-one fight. It was measured by its contribution to the mobility and logistical strength of the entire Allied army. And in that role, it was a war winner. All the technical analysis and battlefield reports ultimately led to one terrifying conclusion, a conclusion expressed not in engineering diagrams, but in cold, hard numbers. As Hauptmann Weber compiled his final report, he requested the latest production intelligence from Berlin. The figures that came back via teletype were a death sentence for the German war effort. During the course of the war, German industry, with all its celebrated engineering prowess, produced approximately 15,250 units of the Sd.Kfz 251 half-track in all its variants. It was a monumental achievement for a nation under constant bombardment. The American numbers, however, were simply from another reality. The United States alone produced over 41,000 units of the M3 half-track family. When including variants and similar models from other Allied nations, the total number of half-tracks produced by the Allies exceeded 50,000. For every single half-track Germany built, the Allies built more than 3. The analysts dug deeper, estimating the cost and time per unit. The Sd.Kfz 251, with its complex hull and precision engine, required over 2,000 man-hours to produce. The M3, using automotive production techniques, rolled off assembly lines in just over 1,000 man-hours, half the time. This reality was not lost on the man in charge of Germany's war economy, Albert Speer. Speer was a logistical genius, but he was also a realist. In his post-war memoirs, he wrote with a sense of dread about American production. They have a capacity for standardization that is terrifying. They are not held back by our traditions of craftsmanship. They build what works, and they build it in numbers we cannot even comprehend. Weber read these production figures to his team of mechanics. The men who had started by mocking the M3 now stood in stunned silence. Their carefully crafted Sd.Kfz 251 was a masterpiece. But Germany could only produce a few dozen per week. The Americans were producing hundreds. The battle between the Sd.Kfz 251 and the M3 was not being decided in the sands of North Africa or the fields of France. It was being decided on the assembly lines of Cleveland, Chicago, and Detroit. And on that front, Germany had already been defeated. The final evaluation report on captured American M3 half-track, vehicle number 403-1128, was a sober and chilling document. Hauptmann Weber's conclusion did not mince words. The report acknowledged the M3's numerous technical inferiorities. Its armor was thin. Its ride was rough. Its open top was a vulnerability. In a direct, one-to-one comparison of engineering sophistication, the Sd.Kfz 251 was, on paper, the superior machine. However, the report stated that this comparison was strategically irrelevant. Weber wrote, "The American vehicle represents a philosophy of total industrial warfare. It is a weapon designed not by engineers seeking perfection, but by factory managers seeking efficiency. We have praised our own vehicle for its quality. The Americans have engineered their entire industrial base for quantity. These are two different approaches to war, and we are losing because we are on the wrong side of the equation." The engineers at the depot had learned a great deal. But the most bitter lesson was what they couldn't replicate. Germany lacked the vast rubber resources to mass-produce tracks like the M3s. They lacked the giant hydraulic presses to stamp out hull components in seconds. Their entire manufacturing culture was built on skilled craftsmanship, not the brutal efficiency of the assembly line. They couldn't simply switch to the American model. They were trapped by their own engineering traditions. This single vehicle evaluation fit perfectly into the larger, terrifying picture that German intelligence was assembling. It was the same story they had discovered when analyzing captured Sherman tanks. It was the same story they had learned from the B-17 Flying Fortress. The conclusion was inescapable. Germany was an industrial dwarf compared to the American giant. They could win battles through superior tactics and sometimes superior technology, but they were losing the war on the spreadsheets of production and logistics. The M3 half-track was not merely a vehicle. It was proof. It was a 9-ton symbol of a nation that could equip its armies on a scale the world had never seen. The German mechanics now understood they were not just fighting soldiers. They were fighting an assembly line that stretched across an ocean, an assembly line that was burying them under a relentless mountain of steel. In the years following Germany's surrender, the conclusions first reached by Hauptmann Weber's team were confirmed again and again. The war had been decided not just by battles, but by production lines. The M3 half-track, the humble battle taxi, went on to have a remarkably long life. While it was largely phased out of U.S. service, thousands were sold to Allied nations. The Israeli Defense Forces, in particular, became famous for their use of heavily modified M3s, which served as their primary armored personnel carrier for decades, proving the astonishing durability of the original design. Its legacy is that of the unsung workhorse. It was not as glamorous as a Sherman tank or as iconic as a P-51 Mustang. But it was the M3 that allowed the Allied armies to become fully motorized, to execute the sweeping maneuvers in France, and to maintain the relentless pace of the advance into Germany. It was the logistical backbone of victory. The story of the German analysis of the M3 is more than a technical comparison. It is a story about the clash of two fundamentally different philosophies. One, the German, was a philosophy of perfection, of creating complex, high-performance machines that were masterpieces of a craft. The other, the American, was a philosophy of pragmatism, of creating simple, reliable, and good-enough machines that could be produced on an unimaginable scale. In a short, sharp war, the German approach might have prevailed. But in a long, grinding global conflict that consumed men and material at an astonishing rate, the American philosophy was destined to win. The mechanics in that dusty depot who first mocked the M3's simplicity eventually came to understand this truth. They were looking at the future of warfare, a future decided not by the quality of the individual sword, but by the factory that could produce 1,000,000 rifles. The M3 half-track was one of those rifles, and it helped arm the free world for victory.